Hello everyone, welcome to my lecture on straight line. How can we define the straight line? A straight line is the set of all points between 2 points and extending beyond the 2 points. So we can say it is the one-dimensional geometrical object. Now we define the slope of a straight line. The slope of a straight line is denoted by m and defined by the formula m equals to tan theta, where theta is the inclination of the straight line with the positive direction of the x-axis. We have another method to find the slope of a straight line. If we have 2 points x1 y1 and x2 y2, then the slope of the straight line is defined by the formula y2 minus y1 upon x2 minus x1. The horizontal and vertical lines. Horizontal lines are those lines which are parallel to the x-axis. If the line lies above the x-axis, then its equation will be y equals to a. And if the line lies below the x-axis, then its equation will be y equals to minus a. Similarly, the straight lines parallel to the y-axis are vertical lines, and if a line is right to y-axis, then its equation is x equals to minus b, and if it is left to y-axis, then its equation is x equals to b. The point slope form. The point slope form of a straight line is defined by the equation y minus y naught equals to m x minus x naught, where x naught y naught is the point lies on the straight line and m is the slope of the straight line. Now consider one example of the point slope form. What is the equation of the line through the point 2 and 4 and a gradient 1? So here we will use the point slope form. Point slope form is y minus y naught equals to m x minus x naught. So by substituting the values of x naught, y naught and m equals to 1, we get the equation of the straight line y equals to x plus 2. Now the 2-point form. The 2-point form of a straight line is defined by the equation y minus y1 equals to y2 minus y1 upon x2 minus x1 and x minus x1, where x1 y1 and x2 y2 are 2 points that lie on the straight line. We again discuss one example of 2-point form. Here we have 2 points 1 and minus 2, 4 and 6. So its 2-point form is y minus y1 is minus 2, so it becomes y plus 2 equals to 6 y1 is minus 2, it becomes 6 plus 2 upon 4 minus 1, x minus 1. And finally, if we solve this form, we get the equation of the straight line 8x minus 3y equals to 14. Next, the slope-intercept form. Slope-intercept form is defined by y is equal to mx plus c, where m is the slope of the straight line and c is the intercept which is cut by the straight line. If c is positive, then the straight line is above, uh, straight line has the intercept above the x-axis, and if uh, c is negative, the straight line has the intercept below the x-axis, sorry, below the y-axis. If m equals to 2 and c equals to 5, then equation of the line is y equals to 2x plus 5. Intercept form. We have another form which is called as intercept form. Intercept form, if we have two intercepts on the positive direction of x-axis and y-axis, that means on x-axis we have intercept A and on y-axis we have intercept B, then the equation of the straight line in the intercept form will be x upon A plus y upon B equals to 1. If we take A equals to 2 and B equals to 3, then equation of the straight line will be 3x plus 2y equals to 6. Next is the normal form. The normal form can be defined as x cos omega plus y sin omega equals to p. So what is omega and what is p? P is the perpendicular to the straight line from origin, and omega is the inclination of the perpendicular with the positive direction of the x-axis. Next, angle between two lines. If we have two lines L1 and L2, then angle between these two lines is defined by the formula tan theta is equal to plus minus m1 minus m2 upon 1 plus m1 m2, where plus sign represents that the angle will be acute angle, and the negative sign represents that the angle will be the obtuse angle, because if two straight lines cuts each other, then we have two angles, one is theta, one is phi. We can consider either theta or phi. If we require acute angle, then we consider theta. If we require obtuse angle, then we consider phi. In case of acute angle, we always begin with the mod sign on the formula. these are two conditions. If the slopes m1 and m2 are equals, then the two lines are parallel. And if m1 m2 equals to -1, multiplication of m1 m2 is -1, then the two lines are perpendicular. So these are two conditions of parallel lines and perpendicularity. Now consider one example on the angle between two straight lines. The first line is 3x plus 4y equals to 6, and second line is x plus y equals to 1. So here we required the acute angle. So here use the formula with mod sign. First of all, convert the straight lines into the intercept form, slope intercept form, and by taking 3x into right side and divide whole equation by 4, so we get y equals to minus 0.75x plus 1.5, and from second equation we have y equals to minus x plus 1. So here m1, this is y equals to mx plus c form, so m1 equals to minus 0.75 and m2 equals to minus 1. So using these two m1 values of m1 and m2 and substituting these values in the formula, we get the angle between two straight lines as theta is equal to tan inverse 1/7. So next concept is intersection of two given lines. If we have two lines in the form of a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, then these are three conditions. That means these two lines are intersecting uniquely, and the condition is this. And if these straight lines are parallel but distinct, then the condition is this. And the two straight lines are coincident, then the condition is this. So consider one example on this concept. The example is, which of the following straight lines are parallel, distinct, intersecting uniquely, and coincident? So first equation is 2x plus 3y equals to 5, 4x plus 6y equals to 10, 6x plus 9y equals to 4, x plus y equals to 1. So first of all, take the first two straight lines, 2x plus 3y equals to 5 and 4x plus 6y equals to 10. We can see these two are coincident because 2 upon 4, 3 upon 6, 5 upon 10. These ratios are same, so these two straight lines are coincident. And if we consider the two straight lines, 2x plus 3y equals to 5 and 6x plus 9y equals to 4, then these are parallel distinct because 2 upon 6, 3 upon 9 is not 5 upon 4. So these are parallel distinct. And if we consider 4x plus 6y equals to 10 and x plus y equals to 1, these are intersecting uniquely because 4 upon 1 is not equal to 6 upon 1. So hope the concepts are clear to you. Thank you.